Hi guys, good morning. Yes, can you hear me?
Yeah, yes, sir. We can hear you. Good morning.
Yeah, thank you. Yeah, we'll start session. Yes, yesterday that introduction discussed Java 11:45. Yes, day one session. So this is day one session. All that complete overview. Yes, day two yesterday. Yes, Java. That complete Java overview discussed Java contents. What is exactly Java? Yes, about complete Java overview discussed. Okay. Yes, let us start about Java features. Java features. Let us see about Java features. Yes, today topic about Java features. Yes. So JDK 1.0 released with main features has begun. Let us see about features here. First one, independent of platform. About this, Java is independent of platform. Independent of platform, portability, next group language, scalability, security. Yes, about these features, discuss. Okay. See, independent of platform, portability, group language, these features. To understand these features, there are some basics required. Some basics to understand all these features. To understand all of these features, some basics are required. To understand all of these features, some basics required. Like about operating system. Yes, about operating system. Yes, independent of platform means here is a OS. OS. How Java made as independent platform. Just to understand it is about OS concept required. Some idea about OS, how OS is working, how OS is behaving. That's knowledge required. 1 second. Yes. About OS knowledge. Next here. Yes, about interpreter knowledge. Yes, about interpreter knowledge. What is interpreter? Next about compiler. About compiler. See, to understand these features, today's topic is about Java features. To understand all these features here, there are some prerequisites, some basic knowledge required, like basics like what is OS, how OS is working, that OS understanding. Next interpreter, so how interpreter working. Next compiler, how compiler is working here. Okay. Next about exe file. So what is exe? Exe file is a OS dependent. So why exe file is OS dependent? That exe file knowledge. Yes, in Java it is a dot plus the dot plus file. Okay. So once you have all this knowledge, then easy to understand these features. Yeah, I can explain directly these features. Simply definitions I can explain. I can go next step. So, but is not that is not my way. So first of all, yes, let us see about all the basics. Yes, if you understand all these basics, then easy to understand all of these features. So first of all, let us see about all these basics. Okay, after finishing this one, next we'll go to these features here. Okay. Yes, not to this even like a generation of languages, even that knowledge, generation of languages. Okay. Once you have this understanding here, once you have all these understanding, then easy to understand all of these features here. Let us start one by one. OS, an interpreter, compiler, exe file, dot class. Yes, all these concepts. Let us see one by one all of these concepts. Okay. Yes. See, So let us start from basics. I'm starting from basics. Yes, before going to Java, there's some basics here, software basics. Okay, starting from software basics. Yes, these basics, even non-IT background guys also can understand. Anyone can understand. Non-IT background guys also can understand. Anyone can understand these kind of basics here. Okay, yes. See, I'm starting from very basics here. See here, computerware. See, computerware. Computerware. See, computerware basically two categories. First one, yes, hardware. Next one, software. Hardware and software. Hardware and software. So computerware basically two categories. First one, hardware. Next is software. Hardware and software. So hardware, yes, this is well known for you. What is hardware? Well known for you. Hardware. So these are physical components of a computer. Hardware. Yeah, these are physical components. Hardware. Yes, these are physical components. They are physical. They are physical components. Physical components of a computer. Physical components of a computer. They are physical components of a computer. Yes, they are physical components. So these are just physical components. Physical components of a computer. Okay, like keyboard, mouse, and monitor. All these physical components. We can touch all these parts, but this is not our part. This is not our part. Yes, our part is software. Our part is software. So let us go to software. So what is software? Let us see about software. What is software? See, software. Yes, niche. Yes, everything is a program. Software, everything is a program. Everything is a program. In software, everything is a program. Yes, it is a collection of programs. It's a collection. It's a collection of programs. It's a collection of programs. It's a collection of programs. It's a collection of programs like C or C++. Yes, C++, Java, and others. It's a collection of programs. Software. It's a collection of programs. Okay. One second. Yes, it's a collection of programs. See, software. Here, software basically two categories. Software. Yes, basically two categories. Two categories. Software basically two categories. Software basically two categories. Software basically two categories. First one, system software. System software. First one, system software. Next one is application software. Next one is application software. System software. Next is application software. See, software basically two categories. Software basically two categories. Software basically two categories. First one, system software. Next one, application software. Software basically two categories. System software. Next, application software. Yes, what is system software? System software. System software. See, this one interacts with the hardware component. System software. See, this one interacts. Yes, interacts with the hardware components. Interacts with the hardware components. Interacts with hardware components. System software. This one interacts with hardware components. Okay. Yes, system software. Example. Yes, operating systems. Operating systems. Operating systems. Okay, operating systems and device drivers. Device drivers comes in this category. Okay, system software. This one interacts with hardware components. System software interacts with hardware components. Okay, examples: operating systems and device drivers. Operating systems and device drivers. Okay. Yes. Yes, application software. Next, what is application software? See, application software. This is for the purpose of application development. Application software. Yeah, this is for the purpose. For the purpose. For the purpose of application development. For the purpose of application development. Application. for the purpose of application development. For the purpose of application development. Okay. Yes. For the purpose of application development. Yes. Applications, apps. See, in our daily life, we are using many applications. In our daily life, we are using many applications. Yes, guys. Anyone tell me some examples of applications? Yes, in our daily life, using many applications. What are the applications? Any examples? Yes, guys. Can you tell me some examples? Yes, in our daily life, we are using many applications. What are the examples here?
Facebook, WhatsApp, Skype.
Yeah, good, good. Yes. So in our daily life, different applications like yes, Facebook is application, right? Facebook is application. Facebook. Next, WhatsApp. So WhatsApp is application. Twitter is its application. Yes. Next, go to training is application. So go to training app, right? Go to training app. It's application. Go to training app. Okay. Yes. Go to training app. So go to training app. Okay. So go to training app. So go to training app. Okay. Yes. So go to training app like company websites. Company websites. There are some applications here. Company websites. Yes. Next, banking applications like this. Many things. Yes. Banking apps. Okay. Online shopping applications. E-commerce applications. Like there are different applications. Okay. Yeah. These applications. Okay. To develop this kind of applications, we need some software. To develop this kind of applications, we need some software. Those are called as application software. Application software. Application software for the purpose of application development, app development, for the purpose of application development. Okay, like Facebook, WhatsApp, Twitter, and all this. Okay, all their applications. To develop this kind of application, to develop such kind of applications, we need some application softwares for the purpose of application development. Okay, yes, application software examples. Best example, Java. Java is application software. Hadoop is application software. Databases are application softwares. Okay, yes, next. Yes, Python is application software. Yes, C language application software, C++ application software. Like there are different kind of things. In application software, there are different kind of things. In application softwares, there are different kind of things. Okay, just like C languages, there are some languages. Yes, in many softwares, right? Yes, around more than 100 softwares are there in the market. It's like some languages. Yes, there's some languages. There are some tools. There are some packages. Language and tools and packages. Languages, tools and packages. Languages like C language, C++, Python, Java, HTML. Next, Perl scripting, Python scripting, like this many scripting languages, like this many languages. Okay, all the languages are application softwares. Next tools, there are some tools like some testing tools like QTP, Selenium, some testing tools. Next, yes, DevOps tools. Next, big data tools, Hadoop related tools, reporting tools like ClickView, Tableau, some reporting tools. Next, some packages like some ERP package like SAP ERP and others. Okay, Oracle ERP, some packages. Yes, all these are softwares. All the softwares here. Okay, see here, all their application softwares. See simple here. So many softwares in the market here. Many softwares available, which is application software, which is system software exactly. Which is system software and which is application software. Okay, simply here. See, OS is a system software. Okay, except OS, all are application software. Simple here. It's very simple. See, except operating systems. all are application softwares. Except ways, all are application softwares. All are application softwares. All are application software. Okay. See here, only ways interacting with hardware components. Only ways can interact with application. Yes, hardware components. Only ways. Only ways can interact with the hardware. Others cannot interact with the hardware components. Only ways. Okay. One second. Yes, only ways. Only ways interacting with the hardwares. Only ways interacting with hardware. Yes, all these soft language tools and packages, no, they can't interact with hardware. So those are the applications. So except ways, all are application software. Except ways, all are application software. All are application software. Okay, fine. Yes, now Java comes with application software. So our part is application software. Our topic is actually it's application software. See, before going to application software, let us see something about ways. What is ways? What is ways? About ways. Here, about ways. Here's some question for you guys. Operating systems. Here's some question. Some question for you guys. Yes. Yes. Try to understand. Which is very simple question. Question is, can we run yes any program yes without ways? Can we run any program without ways? That's a question. Without ways, without operating system. Very simple question. Yes, can we run any program without ways? Very simple question. Yes guys, can we run any program without any ways? Yes, simple question. Can we run any program without ways? Answer is yes or no. Yes, no idea. Can we run any program without ways? Can we run any program without ways?
Yes.
Without ways. Can we run any program without ways? Can we run any program without ways? Yes, answer is no. Ways required. If no ways, no computer. No ways, no computer. Compulsory ways required. Compulsory ways required. Okay. Suppose let us see what is exact ways. Okay. So without ways, we can't run any compulsory ways required. So what is exact ways? That is about ways. What is exact ways? Suppose your laptop. Okay. Suppose your laptop is hardware. Okay. Yes, your laptop, when you purchase laptop here, they will set up OS also. That laptop vendor will set up OS also and will give us right. So hardware on top of hardware, this is operating system. Operating system. This is the operating system. Okay. So what is this operating system here? So what is operating system? What is operating system? What is operating system? Okay. See, hardware on top of hardware OS. So once OS setup is done, your system is ready. So OS is ready. That OS is ready, right? Once system setup is done, OS setup is done, your system is ready. Now this OS is responsible. Suppose this is Windows OS, my laptop, Windows OS. Now this OS is responsible for everything, right? This OS is responsible for everything. This OS is responsible for everything, right? Everything here, right? Yes, suppose. So when you click on this Eclipse, so OS is responsible to launch Eclipse here. Suppose VirtualBox, OS is responsible. WhatsApp, OS is responsible. So here OS is responsible for everything here. OS is responsible for everything here, right? OS is responsible. Okay, yes. See here. So OS setup is done. After that, suppose learning some C language. To learn C language, we have to install C software. Suppose learning C++, you have to install C software. Suppose learning Java, Java should be installed. Java should be installed. Okay. So learning Java, the Java should be installed here. Suppose learning Hadoop, that Hadoop software you have to install. Okay. Suppose database using the database. database has to install on this. So database. So Python. Yes, all these softwares. So all these softwares running on top of OS. All these softwares running on top of OS. These are application softwares. These are application softwares. All their application softwares. All the application softwares. These application softwares running on top of OS. All these application softwares. Okay. Yes. Hardware. On top of hardware, these OS. On top of OS, all these are running here. Like C program, hard C++, Java, Hadoop, database, Python. Yes, all of the programs running on top of OS. All of the programs running on top of OS. So OS giving platform, just it's giving platform. OS just is giving platform. On top of OS, all are running, right? So OS just it's giving platform. So it's giving platform to run all the programs. So OS is acting like a platform. So what is operating system? Yes, simple answer. It's a platform. So what is OS? It's a platform. Yes, it's a platform. So what is OS? It's a platform. OS is a platform. So OS is a platform. Okay. OS is a platform. Yes, where we can run all the application softwares, all the application software. Okay. So what is OS? OS it's a platform. What is OS? It's a platform. So OS is a platform. It's a platform where we can run all the applications, just acting like a platform. So what is OS? It's a platform. So OS it's a platform where we can run all the application software. Okay. So OS it's giving platform. Yes, OS acting like a platform. On top of it, all are running. So OS, what is OS? Means a platform. It's a platform where we can run all the application software. Okay. Yes. Not only platform here, not only platform. Suppose these application softwares generating some output. These application software generating some output. So output of these softwares, first of all delivered to OS. First of all delivered to OS. After delivering to OS here, next transfer to output device. Transfer to output device. Okay, output of all these programs delivered to OS. After delivering to OS, then transfer to output device. Okay, suppose reading from the keyboard. For example, reading from the keyboard. So first of all, keyboard data goes to OS. So first of all, keyboard data goes to OS. Yes, OS to yes, application softwares. Okay, so between application software and hardware, there's a OS. There's a OS. Okay, just 1 second. Yes. So between application software and hardware, there's a OS. So acting like a mediator between these two, right? Mediator means interface. Interface. Just it's interface. It's interface between application software and hardware components. So one more point about this. Yes, it's an interface. It's an interface. It's an interface. It's an interface between application software. It's an interface between application software and hardware components. And hardware components. And hardware components. Just acting like interface. So why is acting as an interface? It's acting an interface between between application software and hardware components. Hardware components, right? Yes. Next here in OS there is a library. Okay, OS libraries. There are some libraries. What is library? Library contains all the functions, C language functions. Operating systems were developed in C language. All the C language functions. Operating systems like Windows OS developed in C language. Next, Linux OS developed in C language. Unix OS developed in C language. All the C language functions. That library is a collection of functions. Some input-output functions. Library contains C language input-output functions to perform I/O operations. I/O operations between application software and hardware components. Okay, so every OS has its own library. Every OS has its own library to communicate between application software and hardware components. Okay, See here, every OS. Yeah, this is important point for Java perspective. For Java perspective, it's important here. See, every OS has its own library, has its own library, its own library, its own library. Yes, every OS has its own library. Every OS has its own library. Yes, to communicate, to communicate. Yes, to communicate. Yes, to communicate between, to communicate. Yes, to communicate between application software and the hardware components. To communicate between application software and the hardware components and hardware components and hardware components. Okay, so your OS, it's a platform. Yes, see, every OS there's some library. So every OS has its own library. Okay, one second. Yes, sorry. Yes, every OS, yes, has its own library. Every OS has its own library to communicate between application software and hardware components. Okay, see here, suppose C program, C++, Java, Hadoop, these programs. Before going to run it, first of all, yes, all these programs, first of all, links with OS library. Of linking with OS library, then communicates with the hardware components. Yes, it has to link it compulsory here. So every program, maybe C program, maybe Java, maybe Python, all these programs have to link with OS library before going to run it. It's a compulsory here. Okay, so using library only communicate with hardware components. Okay, see every program, see every program, see, so every program has to link with OS library, has to link with OS library. So every program has to link with OS library, yes, to communicate with hardware before going to run it here. So every program has to link with OS library, yes, before going to run it. Yes, before going to run it. Before going to run it. Okay, get that linking. Sometimes static linking, sometimes dynamic linking. Statically linking and dynamically linking. Suppose C and C++, it's a statically linking. Okay, C and C++ is statically linking. Okay, yes. What is yes? C and C++ is a statically linking. Okay, in Java, Python, dynamically linking. Dynamically linking, statically linking, and dynamically linking. The topic we'll discuss next. Yes, what is statically linking? What is dynamically linking? We'll discuss next. See library. What is OS library? Means library is a collection of functions. It contains all the C language functions. Library is a collection of C language functions. Okay, so every way is developed in C language only. C language functions, input output functions. Library contains C language input output functions. It's a collection of functions. C language input output functions. So what's the purpose of input functions? To perform I/O operations with hardware components. Performing I/O operations with hardware components. Okay, that's about library. Okay, so every program has to link with OS library before going to run it. Okay, so this about OS. Get this introduction enough. Yes, fourth point is very important for us. Okay, very important for us. Yes, Java program linking with OS library before going to run it. How is Java program linking? The topic we'll discuss next. Okay, so this is about OS. This knowledge enough about OS. About OS. Okay, yes. So systems are yes. Let us go to document. Yes, your class document. See, this is your class document. Java. So your class document. Yes. So today topic, introduction to software. It's a collection of programs such as C, C++, Java, SQL, and other programs here. Software basically two categories: system software, next application software. System software, same points explained here. It interacts with the hardware components. Example, device drivers and applications. Application softwares. This for the purpose of application development. Example, C, C++, Java, .NET, ERP and others. C except OS. Except operating systems, all are application softwares. So next, device driver is to run the devices. Okay. Next, OS. This is our topic. Same, all that 4 points what we discussed in prepared in documents. Same thing here, it's there. Okay, you guys don't worry about notes. So here not required write any running note. Running notes not at all required. Just to follow document enough care. Okay, this document for you only. I'll share with you. This document for you only. I'll share with you. Okay. Yes. So this is about OS. Okay, fine. Now, yes, Java is application software. So let us move to application software. What is application software? See, application software. So this is for the purpose of applications development here. Okay, in this, yes, there are two types again in this, two categories, front end and back end. Front end software, next back end software. So what is front end? What is back end? What is front end? What is back end here? Front end software. For example, here, see, here's some form, right? Form. Here's some form. Okay, here's some form. Yes, in this form here, see, first name, last name, email address, phone number, right? Something like this. Some form like this. Here's some form. Okay. Now we are filling form, then register, right? So once you click on register, what happens? Filling form, yes, right? Yes, filling form, and submit that information. Filling form, submission, right? Once submitted, what happens? This data, all this data goes to some location, storing at some location, right? So this form called as front end here. So this form is a front end. This form is front end. So this is interacting with this, right? Taking data from us. Taking data from us. We are submitting data here, right? Okay, so this form taking data. So this interacting with the users, right? We are the users. So this form interacting with the end users. So that means front end interacting with the end users. End users, right? So behind of this one, yes, some Java program is there. Behind of this form JSP. JSP is a Java server pages. It's Java program. That program taking data and storing it some location. That location is called as backend. Backend is to store the data. So front end is to collecting data. Front end collecting data, interacting with the end users, collecting data and storing into backend. Storing into backend. Storing into backend, right? Okay. So front end, backend. See front end. Yeah, these are to interact with the end users. It collects data from end users and stores in the backend. Okay, so backend, these are to store and maintain data, storing and maintaining data. Example, databases and files. Okay, so Java comes under front end. Java comes under front end. So let us move to front end. Our topic is now front end. In front end, there are language and packages. In front end, again, two categories like language and packages. See, package. Package is ready-made and ready to use. Ready-made and ready to use. It's ready-made and ready to use. For example, MS Office is a package. See here, all these predefined options. New, open, save as. Okay. Next, home. In these different options, right? Insert different options. All predefined options. So using the options, ready-made options. Okay, and prepare the document that it's a package. It's a package. So Tally ERP package. Ready-made one. That all the forms are fill the form, submit. That's it here. So the package is ready-made one. So you can nothing to write any code. No programming, nothing here. Code is not necessary. Programming is not necessary. Yes, if it is language, we should write the coding. In language, we should write the coding here. So Java comes on languages. So let us move to language now. See how I am introducing to Java. Java introduction. See this. So first of all, computer hardware and software. Hardware and software. So our part is software. So started software. In the system software, next application software. Java is a application software. So that's the reason just move to application software. Yes, in application software, front end, back end. Java is a front end. So move to front end. In front end, language and package. Java comes in languages. So that's the reason move to language, right? Yes. Now our topic is about languages. Let us say about languages. Yes, languages. Yes, language. What is a language? See, what is a language? See, we are speaking many languages. In our daily life, yes, using many languages. Depends on person we are facing. We are using that language, right? Like, like English, Hindi, maybe Telugu, Marathi, Kannada, Gujarati, like that. We're different language we're using, right? What's the purpose? Communication purpose. Just communicating your ideas, communicating your requirements, communicating some information, communication purpose. So what is a language? It's a media of communication. Language is a media of communication between two things here. Just it's a media of communication. Okay. Yes, come to software. Yes, software languages. Software. Software languages. Software language. Come to software. See in software here. See, compete in software, computer. Yes, computer understanding some language. Computer understanding language. Understanding some language, right? Computer understandable language. Computer understandable. So computer understandable language. Okay. So computer understandable language. Next, we are understanding some language. We are the users of computer. So user understandable language. See, computer understandable languages. Also, computer understandable languages. Next, user understandable language. So these two things here. So computer understanding some language, user understanding some other language. So what is computer understandable language? What is computer understandable language? Let us say about computer understandable language. Computer. Yeah, there are different generation of computers. Different generation of computers understand different language. How many generation of computers? Any idea? How many generation of computers? Generation of computers. How many generation of computers? Any idea? Generation computers. You have 5 generations. Okay, fine. 5 gen. See, first gen, first generation. What is first generated computer? Any idea? Yes, vacuum tubes based. So vacuum tubes based here. Okay. So first generation. Second generation. What is second generation computer? Second generation computer is what? Transistor based. Transistor. Transistor based. Okay. Transistor based computer. So what is next? Third generation. Third gen computer. Third generation. Yeah, third generation is what? Third generation IC. Integrated circuits. So IC based. IC based. Integrated circuit based. Next, fourth generation is processor based. Yes, processor based. So processor based. So this is present generation. So presently we are using this one here. Present generation. Present generation. This is present generation. Present generation. Okay. So present generation computer is processor based generation. Okay. Now what is computer understandable language? Computer understandable language. You say processor understandable language. Computer understandable, processor understandable language. Now we are using processor based computer. You can say processor understandable language. Processor understandable, processor understandable language. Processor understandable language. Yes, it's a binary code. It's a binary code. It's a binary code. So binary code like a zeros ones format. Zeros ones format. Binary code zeros ones format. So processor understandable language. It's a binary code. Okay. Yes. Now currently we are using 8086 processors. In 90s 8085 used. In 90s 8085 used. Now we are using 8086 processor here. So 8086 processor. It's a binary code. It's a binary code. Okay. Now currently we are using processor based computer. So processor based computer, it was released in the year 1970. 1970. Processor based computer is 1970 computer. 1970. Okay. Yes, after that, next generation is, yes, sorry, processor based 1970 here, 1970. It's a processor based language, binary code. Next is C language. C is a high level language. Yeah, the topic we'll see next year. Next, fourth generation, next fifth gen computer. See, fifth gen computer. Okay. So processor based, now presently we are using processor based computer. Processor based computer. Fifth generation. What's a fifth generation? Means next coming. Yes, maybe couple of years releasing market. Next coming to the market in couple of years only. Maybe 2024, 100% getting into markets. What is that line? What is that one here? Fifth generation. Anyone idea? So what is fifth generation computer? Next generation, fifth generation. Maybe couple of years, 2024. Yes, releasing the markets. What is that? Any idea? Yeah, right. AI based, artificial intelligence based, not cloud. Cloud is storage. Cloud is storage. Cloud computing, that is storage. Cloud is storage. Okay, AI based, artificial intelligence based here. AI based, it's a feature coming. So AI fifth generation is a feature coming. Now currently we are using fourth generation computer, processor based, fourth generation. Okay, so fourth generation, right? So there are different generation of computers. See here, why I am giving this much of information means you must have every knowledge. Yes, as a software engineer, you must have every knowledge. That's the reason, including this information also I'm giving here. Yes, generally in my classes I use a lot of information about software. Okay. Yes, every class, even Java also, yes, very depth I'll go here. Every lot of information giving. Because here once you, yes, once you attending interview here, every topic you have to answer, including basics also. Okay. See, so here software engineers who are having 10 years of experience, 20 years of experience, just you ask them, anyone can explain this? No one can. How many generation of just ask your friends who are already working in software field. Just you ask your friends, 99% they will fail to answer this one here. The generation of computers. They don't know. Simply learning software and working. Yes, as a software engineer, you must have every knowledge. Yes, gathering lot of information. Always you should gather the information. Lot of skills. You have to gather. Yes, you have to learn lot of skills on information and all this. So for information purpose, I'm explaining all of these things. You must have this knowledge here. Knowledge. Okay. Yes. So fifth generation AI based. Maybe 2024 will be releasing here. Okay. Yes. Now, so this is fourth generation is a processor based. So processor based, processor understandable language. It's a binary code. Okay. So processor based language, binary code. So this is called as low level language. Low level language. Next, user understandable. So what is user understandable language? User understandable language. For example, here, suppose Java program. Java program. Suppose this is some Java program. See, it's like English language, right? It's like English language. Suppose some Python scripting. Python scripting. For example, Python scripting. Python. Yeah, this also looks like English language. Like English language. Like English language. Suppose C programming. C programming. Also like English language. C programming. Suppose some C program. This is like English language. Okay. So these are what like English, like they're called high level language, user understandable language. These are user understandable high level languages. High level language. Okay. So system understandable is a low level language. User understandable is a high level language. So languages are two categories. In software, languages are two categories. Yes. Low level languages. Low level languages. Next second one, high level languages. High level languages. Low level language and high level language. Okay, low level and high level. Low level language. Yes, it's a system understandable language. System. 1 second. I need to have some water. Yes, low level languages. Yes, it's a system understandable. It's a system understandable. It's a system understandable language. It's a system understandable language. Okay, it's a system understandable language. Okay, yes. See, it is in the form of binary. It is in the form of. It is in the form of binary code. It is in the form of binary code. Binary code. So it's like a zeros ones format. Zeros ones for binary code. Zeros ones format. Just zeros ones format. It is in the form of binary code. In the form of binary code. It is in the form of binary code. Zeros ones format. Okay. Yes. It is called as machine language. It is called as machine language. Called as machine language. It is called as machine language. Okay, machine language is called as machine language. Okay. Yes. Here system means processor. System means system understand. System means it's a processor understand language. Processor. Okay. It's a processor understand language. Processor understand language. Okay. Yes. Processor understandable. Understandable. Sorry, what's happening? Understandable. Processor understandable language. Is a processor understandable language. Processor understandable language. System means it's a processor. Processor system understandable language. Processor understandable language. Processor. It's a processor. Yes, it's called as machine language. Machine language. Yes, it's a first generated language. Machine language is a first generation language. Yes, in languages there are different generations. Yeah, that generations also will discuss. Don't worry. Generation of language. Totally 4 generations here. Yes, in four, yeah, there first 2 generations are low level languages. Next two, yes, high level language. First, second, third, and fourth. Totally 4 generation of language. 4 generations here. Yes, first and second low level language like machine language, assembly language. These two are low level language. Yes, high level language, third and fourth, like procedure oriented and functional oriented. Yeah, this topic we'll discuss next. Just wait, I'm holding this topic. We'll see next. The generation of language we'll see next. Let us continue with our topic here. Okay. Yes. Low level languages. It's a system understandable language. It is in the form of binary code, zeros and ones format. Yes, it is called as machine language. System means it's a processor understandable language. It's a processor understandable language. Okay. Yes. Next, what is high level language? High level language. Yes, it is a yes user understand language. It is a user understandable. It's a user understandable. User understandable language. It's a user understandable language. It's a user understandable language. Yes, it is like English language. Yes, it is like a it's like English language. Like English language. Like English language. Like English language. Okay, it's like English language. It's very easy to understand. Okay, C language. C language is a functional oriented language, not OOPS, not procedure. C is a functional oriented language. C comes under functional oriented language. Yet the topic will discuss functional oriented languages, procedure oriented languages, OOPS language will discuss next. I will explain very clearly. Wait. Okay, wait for some time. I'll explain clearly. Okay. So high level language. Okay, high level language, low level language, right? See, high level language. Yes, like yes, Java, it's a high level language. Yes, Python, it's a high level language. Next, C. is a high level like C programming, also high level language. C is a first high level language. C is a first high level language. In high level language, C is a first high level language. It's a functional oriented language. C is a first high level language. Okay, they are high level language. See, system cannot understand all the high level language. Okay, system can't understand high level language. This high level language may be C program or C++ or Java, Python. This high level language code has to convert into binary code. Okay, high level language. Yes, high level language. Yes, should convert into binary codes. After converting to binary codes, then execution here. Yes, who will convert? Which one will convert here? From high level language to binary code here. Okay, from high level language to binary code. Binary code means system understand language here. Who will convert? Yes, someone has to convert. Okay, so high level language to binary code. Who will convert it here? For this, either interpreter or compiler. Either interpreter, either interpreter, either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler converts. Yes, converts from high level language to binary code. Okay. Yes, either interpreter or compiler converts from high level language to binary. Yes. What is interpreter? What is compiler? This is very, very important for Java. Yes, to understand Java features, you must have this knowledge, interpreter and compiler. Okay, about OS knowledge, how OS is working, that point clear. Now how interpreters and compilers working. If you have that knowledge, then easy to understand Java concepts. Okay, so let us see about interpreter and compiler. Interpreter versus compiler. What is interpreter? What is compiler? See, interpreter and compiler both are to convert from high level language to low level language, means binary code. High level language to binary code, but the way it's working is different. The way it's working is different. Interpreter versus compiler. Yes, how these are working? Let us see. Okay, for interpreter purpose, I'm taking Python example. Python is the interpreter based language. Okay, the Python source code. Yes, Python source codes. Python source codes. Test.py. The Python source code. Test.py. Python script file. Python scripter. Yes, 1 second. Python example. D drive. Mn Python folder. Yes, Python folder. See this Python folder. This is test script is available. Okay, test.py. D drive Mn Python. Yes, see to develop the Python applications, Python scripts you can use PyCharm. PyCharm, using PyCharm we can develop. Okay, we can develop it. But for understanding purpose, I'm using Notepad now. Notepads. See command prompts. Command prompts. Where the script is available. D drive Mn Python folder. D drive. Let us go to D drive. D colon will take to D drive. Okay, DR. Yes, in this Mn Python folder. Okay, CD. Yes, Mn Python. CD means change of directory. CLS, screen clears. Okay, yes, after this, not DR. So they say test.py, then Python script. Yes, not patch. Test.py. Python script. See what is the script here? A equal 10, B equal 20. So A value 10, B value 20. After assigning C equal to A plus B. So performing addition of two numbers. Subtraction of two numbers. Multiplication of two numbers. So this is Python script. Okay. Right. Now, how to run this script here? Python is interpreter. So this the Python interpreter. Interpreter taking yes. Got the output right. So directly execute it. Suppose if it is C program, first checking for errors, right? First compile. If it is C program, compilation. If it is compilation, first compilation checking for all errors. If no errors, then executing, right? Okay. Yes, Python script directly execute it. It's interpreter directly executed here. Okay. So how it's working here? How this interpreter is working here? Okay. The Python script. Python script. There are some statements. First statement one. First statement. Next statement. Yes. All they are called as statements. Programming statements here. First statement. Next statement. Next statement. Next statement. Next statements. Okay. Suppose C, C plus Java, every statement terminate is semicolon, but in Python not necessary, optional. Optional. So line by line. So this code is line by line code. Scripting just line by line. First line, next line, next line, next line, next line, like this. Okay, this Python script is like this. Okay, yes. Now how this is working? This script. That's how it's working here. How it's working. The Python script interpreter. How interpreter working on the script? Let us see about this interpreter. Okay. In this some statement, suppose the script A equal 10 first statement, yes, B equal 20 second statement, okay, C equal to A plus B third statement here, next printf addition equal to, okay, next C equal to A minus B next statement, okay, next subtraction equal to printf subtraction, next multiplication here, next multiplication, some statements like this. There are some statements in the script here. There are some statements. Okay, there are some statements here. Some statements like this. Some statements. Yes, how interpreter working here? See, interpreter checking first statement, first line, checking first line. Okay, suppose if it is correct, the statement simply converts into binary code, binary formats, zeros ones formats, zeros ones formats. After converting into binary formats, that will be given to processor. So processor taking the codes and generating outputs over first line completed. See, next coming statements may be right or wrong. Next coming statements neither right or wrong. Yes, interpreter never think about next statements. Next statement may be right or wrong. Yes, it won't think about next coming statements. If the statement is correct, immediately converts into binary code and generating output. Over first statement completed. Completed. Next, checking for next statements. Suppose next statement is correct, same process. Same process. Same process. Converting into binary codes. So just the converting into binary codes and generating output here. Yes, checking for next statement. Suppose next statement, something wrong here. Something wrong, simply stops. Something wrong here, simply stops. This is working of interpreter. So interpreter checking first line, if it is correct, then execution immediately. So first line completed. Next checking for second line is correct, then execution means line by line. First line checking, execution completed first line, next line checking complete, so line by line. Okay, any error comes, simply stopping. Any error comes, simply stopping. See this. Yes. So any error comes, simply stopping, right? It won't go for next coming statements. Only one error. It shows only one error. Suppose next statement maybe some mistakes are there. No, it won't show any next mistakes here. Once mistake comes, simply stops here. Any syntax error, any mistake simply stops. Simply stops here. See, let me show that practically here. Yes, notepad, test.py, the script. So A equal 10, B equal, suppose something here mistake. So comma missing here. Comma missing, suppose here some bracket missing here. Suppose here some double quotation missing. Something missing. Save. Save and exit. Saved. After saving, yes, now run it here. See, just I'm using up arrow key to get the previous comments. Yes, every time typing is not necessary. Yes, yes, up arrow key dash, it can remember previous comment. History, it will maintain history. Up arrow key, up arrow key, up arrow. Yes, now Python that's running, right? Yes, yet. Seventh line error. Actually, there are 3 errors. In program, 3 errors are there, but showing only 1 error. So any error comes, simply stop me. Line number 7 error. Line number 7. So it's not showing all the errors, only one line. So any error comes, simply stops. So here stopped, here stopped. So this line error, right? That error, yes. After correcting errors here, now again run it here, again run it. After correction, run it. Yes, now 11th line error, right? So next error showing. So it's not showing all the errors at a time here. Only one error. So any error comes simply stops here. Any error comes simply stops. So 11th line error here, right? 11th line. So this statement error message. This is error, right? Error. Save. Okay, exit. Now, yes. Again submit here. Yes, now 16th line error. Like this, only one error. So one by one error here. Correcting, right? Okay. Yes. CLS clear the screen. Yes. Now next error. Next error. Here this is mistake. Here error, right? Here error. Okay. Yes. Now run it. Yes. Complete it. So it shows only one error. It won't show all the others. So this is working of interpreter. So line by line working here. Yes. If statement is correct, immediately converts execute. So line by line checking and line by line execution here. Line by line working, line by line. Any error comes, simply stops. So this is interpreter working. Next compiler. How compiler works? Let us see about compiler. How compiler working? Yes, compiler. C compiler. Compiler. Suppose source codes. For the compiler purpose, I'm taking C program. Test.c. Some test.c. C program. Okay. Yes, how it's working. Compiler. Yes, C program. Checking first statement. C program. Let us take some C program. C program. Here, this is C program. Okay. Same. Addition, subtraction, multiplication of two numbers. C. STDIV data is conv data is main function. Yes. Main function. Yes. Int A, B, C. Three variables declared. Enter first number, second number, third number. Yes, sorry. C equal to A plus B. After reading two numbers. After reading two numbers. C equal to A plus B. Addition. Next subtraction. Multiplication. Right. Yes. How it's working here. See. Alt C for compilation. Only compilation. Alt C compile success. No alter on it. Then yes 20. So output got right. So what happens here? First compiling. Alt C compiles. If no error message, then running. When you're running this, what happens here? Yes. First of all, create one exe file. For this purpose, just creating one exe file. It will create one exe file. After creation of exe file, it will run. Okay. Yes. Here, suppose some mistakes. Yes, there are some mistakes in program. Suppose here semicolon missing. So printf double quotation missing here. Okay. Suppose here some comma missing. Some statements missing here. Suppose here bracket missing. Some statements. Okay. Here some semicolon. Some here some bracket missing. Alt C compile. Now it's compiling, right? Yes, error message. How many errors? Totally 9 errors. Means top to bottom all the errors showed here. See, press any key. See, this is first error. See at the bottom you can see all the errors. Declaration syntax 16th line error. Next line number 21 error. So next error, next error. Yes, next 25th line error. Yes, 27th line error. 33 line error here. Line number 33, line number 30. All the errors from top to bottom. All the errors from top to bottom. So compiler checking here, compiler checking from top to bottom. Yes. What happens in case of compiler? What happens here? Here compiler. So compiler, see compiler checking for the first statement. So our first statement is correct. Even it's correct here. No, it won't convert into binary code immediately. No, it won't convert. It won't convert into binary code immediately. Checking first line. Next, checking second line. Second line also correct. It won't convert into binary code. Okay. Yes, checking first line, checking next line, checking next. Suppose something wrong, error at third line. It shows error at some line here. After that, checking for next line, checking for next line. If it is correct, then goes to next line, goes to next line, checking for next line also. If it is correct, next line. So like this, top to bottom. Okay, suppose something wrong here, it shows error, error at some line here. Yes, after that, next line, checking for next line, checking for next line. So next, checking for next line, checking for next line. So like this, top to bottom, compiler checks the whole program from top to bottom. Okay, yes, and shows all the errors. Suppose next error, like this, top to bottom. So top to bottom, compiler checks whole program from top to bottom and shows all the errors. All the errors. So here error, like this, all the errors. See, in case of interpreter, what happens? Only one error. Interpreter, any error comes to the stops. Any error comes to the stops. Interpreter shows only one error. But compiler shows all the errors from top to bottom. Compiler checking whole program from top to bottom and shows all the errors. And shows all the errors from top to bottom. Compiler shows all the errors. Interpreter is only one error. Okay, right? Yes. No. Let us correct all the errors. Correction of all the errors. No correction. Here semicolon missing. Yes, next here double indentation missing here. Yes, next here comma missing. Here comma missing. Okay, some statements missing here. Suppose here bracket missing here. Bracket missing. Okay. Yes. Now recompile. Yes, again errors. Again errors. Now here this is error. Okay, compile. Success, right? Success. No run it. Yes. So program execute, right? Suppose if no errors, what happens? Let us see. If no errors, what happens? How it's working here? Let us see. So here correction of all the errors. Correction of all the errors. Correction of all the errors. From top to bottom, correction of all the errors. After correction of all the errors, recompilation. So when recompiles, yes, after correcting recompilation of error, program file here, recompilation, suppose on recompilation, no error. Everything is fine. Everything is fine. What happens here? Okay. If no error, what happens here? Then compile opens another file. Compile opens another file. Opening another file here. Opening another file. After opening another file here, yes, compile opens another file. After opening another file here, this whole code converts into binary formats. All the lines, top to bottom, all the source code, this kind of source code. This source code, no errors. If no errors, this all the source code converts into binary formats and write to another file. Write to another. So binary zeros ones format. Every statement converts into zeros ones format. Binary format, just to convert into binary format. All the statements from top to bottom. Okay, checking whole program from top to bottom, converts to binary code and write to another file. Yes, this file is called as exe file. It generates one exe file. Exe means executable file. It's a system understandable language. So one exe file generates. One exe file for this whole code, for the whole source code, converts into binary format. Then exe file generates. Now this exe file given to processor. So processor taking that exe file and at a time executing and generating output. See, in case of interpreter, what was happened here? Line by line. Is line by line. But in case of compiler base here, one exe file generates. That exe file executes and generating output. Giving output, right? See what happens here. Behind of this one exe file generates. Yes, 1 second. I'll show that point also. Suppose main. So display compile success. Now when you try to run it, it will create one exe file. When you try to run it, creating one exe file, run, creating exe this. Exe file, math.exe file, right? Math.exe file. Okay. Yes, try to run it. Is that math.exe file? Yes, linking and creating one exe file. Creating exe file, right? At the time of creation of exe file, now it's looking for main methods. Main is not. Yes, to compile the C program, main function is not necessary. Without main function also, C program can be compiled. C program can be compiled without main function also. But to run it, first it will create exe file. Yes, before running, just creating exe file. To create exe file, looking for main C, linking math.exe file, math.exe, that means it's creating one exe file, Now main placing. Okay, yes, compile, yes, run it. That's it. Exe file created and executed here. Okay, that math.exe file created, math.exe file created. So backend. So behind of that backend, one exe file creates. See exe file. See here C drive, turbo C TC, turbo C. Yes. When that exe file math. See math. This is our program. Math.cv file. CPP. CPP or C language, both are same. This is that math.cpp file. Yes, math.exe. See 12:50 now. Time is 12:59. Just now exe file created. See, suppose I'm deleting that exe file. Delete exe file, delete it. Now I'm running. Yes, alt R. See this. Just observe back and here. That create one exe file running here. Run it. See that back and exe file created now. 1 o'clock just now exe file created. So back and one exe file created. That exe file executed. That's it. So what happens if no error generating one exe file? That exe file executes. Simply exe file executes. If no error, then generating one exe file, generating exe file, that exe file executes. So this is yes, compiler interpreter working is like this. Compiler interpreter working is like this. That is the points wise differences here. So interpreter versus compiler. So about interpreter practical explain, compiler practically we discussed. Now let us compare these two. For better understanding, yes, I'm comparing these two. Yes, interpreter, next compiler, interpreter, next compiler. So what's the difference between interpreter versus compiler? Differences. See, first point, interpreter. Yes, interpreter. Yes, checks the code. Interpreter checks the code. Checks the code line by line. First line checking. Yes, after finishing first line, then goes to second line. Line by line, only one line at a time. Line by line. Yes, what is compiler whole program? So compiler, yes, it checks whole code. Yes, whole code from top to bottom. It checks. See, it checks whole code from top to bottom. From top to bottom. Whole code from top to bottom. Right? See here, interpreter output. First line checking if it is correct, generating output here. So it generates output. See, it generates output line by line. The output are line by line, output here, line by line. Output are line by line. It generates output line by line. Compiler, see, creating one exe file. That exe file at a time executing, right? So at a time output. It's at a time output here. So at a time output here. It's at a time output. At a time output. Okay. Yes. Next, interpreter. Any error comes, simply stops. Any error simply stops. So it shows. Yes, it shows only one error. Only one error. It shows only one error, right? It shows only one error. Only one error. Only one error. Compiler, yes, it shows. Compiler shows all the errors. It shows all the errors. All the errors from top to bottom. Shows all the errors. Okay. Next, main important point is exe file, right? The difference you observed. Exe file, interpreter based language. Yes, for example, Python. See, Python is what's happening directly, that script submitting, right? The source code directly submitting. We are not compiling, we are not checking in errors. No exe file creation. Directly it's working. Simply. Directly working means no exe file concept. No exe file concept here. Okay. See interpreter. Yes, it does not generate. It does not generate exe file. It does not generate exe file. Compiler, it generates exe file. Generates exe file. So this is main difference. Main difference between interpreter and compiler is compiler generates exe file. Interpreter does not generate exe file. Right? Interpreter does not generate exe file. See, interpreter based. See, it executes source code directly here. It executes source code directly. Executing source code direct. No errors checking, nothing can. See that source code. Yes, that test are clear. The source code executing directly. No errors checking, nothing can. Directly executing. Right? But in case of compiler, what happens here? Yes, it executes exe file. It generates one exe file. It generates exe file. After that, it executes. It executes exe file. It executes exe file. Okay, right? Yes. Now interpreter based. See, interpreter based language are scripting language. They are scripting language. Languages. These are programming language. It's compiler based is a programming languages. Compiler based is a programming languages. So compiler based is called as programming language. Interpreter based is scripting language. Script means that can be modified anytime. Scripting can be modified anytime. Suppose Python scripting, HTML scripting, Linux shell scripting, this scripting language, that code can be modified anytime. But programming language, suppose C programming or C++, these kind of things, you cannot modify directly. Lengthy process. If you want to modify that code, lengthy process. But here, Python script, open script and modify. Just open the script and modify. Simply easy to modify here. So scripting means that can be edited anytime. Scripting can be edited anytime. Editing anytime. So scripting language. Yes, examples here. For this example, Python is the best example. Python. Next HTML. HTML code. See this HTML, for example, here. Suppose Advanced Java folder. Yes, Advanced Java material. Yes, HTML folder. See HTML folder in this. Yes, in this login form. They say login form. Like this login form. Here this is login form. Okay. Here this is login form. User ID, password, login form. So this is this HTML script. Yes, right click and open. Yes, direct opening the browser. HTML is a browser understandable language. Browser is the interpreter for the HTML. Browser is the interpreter for the HTML. Browser is the interpreter for HTML here. Okay, HTML. Okay, next. So Python, HTML. Yes, next. PHP or Linux shell scripting. Yes, PHP. Yes, Perl scripting. Next, JavaScript. JavaScript is not a Java. JavaScript is different. Java is different. JavaScript is a browser understandable language. JavaScript is a browser understandable language like HTML. Java is a JVM understandable language. So Java different, JavaScript is different. These are scripting languages, programming languages. So these are C is a programming language, compiler based. See, these are the interpreter based language examples. Compiler based C language. Next C++. Okay. Next .NET C#. So they are compiler based language. Okay. See, interpreter based language. Interpreter. Yes. Interpreter based language. Interpreter based language. Yes. Don't have exe file, right? No exe file concept for the interpreter based language. Python scripting. No exe file. Directly Python script executing. HTML. For HTML also no exe file. Shell scripting. For all this. Okay. Yes. For all this here. For all this. Okay. Yes. For all this. Interpreter based language don't have exe file. don't have exe file. Interpreter based language don't have exe file. There is no exe files for the interpreter based language. Here everything is an exe file. Everything is an exe file. Everything is an exe file. Fifth pointer, see, it executes, interpreter executes source code directly. See, in case of Python, test.py is a source code. Test.py, not dash. This is source code. This source code, that source code directly working here. Yes, executing source code. Python interpreter executing source code directly executed. But C language compile based. What happens here? Backend one exe file creates. When you run this, one exe file creates. That exe file executes. Okay. In the backend of this ID, one exe file creates. That exe file executes. Okay. So interpreter based language directly source code executes. Yes. Yes. Compile based it executes exe file. Is it clear now? It executes exe file. Okay. Yes. No, interpreter based language don't have exe file. Interpreter based language don't have exe file. Yes, compile based everything is an exe file. So this is difference between interpreter and compiler. Yes, some surprising thing here. Surprising. See, I'm talking about many things like C language, C++, Python, HTML. So it's very Java now. Actual topic is Java, but I'm not talking about Java. Now, what is Java? Is it interpreter based or compiler based? So what is Java? Yes, any guys? Yes, anyone idea? What is Java? Let us see about Java. Is it interpreter based or compiler based? Okay, is it interpreter based or compiler based? What is Java? Let us see about Java. Yes. What is Java? See, except Java, other languages. Other language, what happens here? Other languages. Except Java, other languages, source code, maybe C program source code or Python source code. That source code converts into binary codes. Source code converts into binary code. That binary code is given to processor. That binary code given to processor. So processor taking that code and executes and generating outputs. Okay. Source code converts into binary code. Source code to binary codes. Maybe either compiler or interpreter. Only one thing is working. Suppose Python means interpreter converting. C program compiler converting. C++ compiler. So HTML interpreter. Okay. Yes. Case of other line except Java. Yes. In Java, what happens? In Java, what happens here? In Java, first source code. Yes, converts into one byte code. That byte code converts into binary codes. This part binary codes. Okay, first of all, source code converts into byte code to binary code. So except Java, other language, only one step, source to binary code. But in Java, there are two steps here. First step is source to byte code to binary code. This is first step. Source to byte code. First step. Source to byte code. Yeah, this is by the compiler. Okay. In Java, errors taken by the compiler. Let us see Java also. D drive. See the backslash taken by D drive. Here. Java program. Suppose test direct CD test. Change CLS. Here. 1 second. Java. Yes, notepad test.java. Notepad test.java. It's open here. So Java program is like this. Hello world program. Simple program. Okay. Now, first you have to compile it. Like a C program, here also a compilation. Like a C language, first you have to compile. Like a C language, this should be compiled. Actually, Java in Eclipse. Generally, in Eclipse, we can use Eclipse to for the development. Yes, in our classes, we'll be using Eclipse only. In real time, also Eclipse here. Yes, Notepad, no one use. Yes, here Notepad. The Java program open Notepad, right? Notepad, is open Notepad. Yes, we will not use Notepad actually. For understanding purpose, I'm showing Notepad now. Understanding purpose. Understanding purpose. No Java C, I'm compiling that code. Java C test.java. See this test.java I'm compiling. Test.java I'm compiling. Yes. Compiled. No error. Yes, no error. Okay. So test dot class file generated. Which bytecode file? This is called bytecode file. What is exactly bytecode? We'll discuss next page. So compilation is done. Compilation process is done, right? Compilation is done here. Source code to bytecode by the compiler. Okay. Source code to bytecode by the compiler, right? Okay. So here in Java, what happens here? Yes, in Java, yes, compiler checks for compiler, compiler, compiler checks for errors. Compiler checks for errors. Compiler checks for errors. If no errors, then it generates dot class file. Generates one dot class file. That's it. So this is source code to bytecode. Next, bytecode to binary code. Next step is bytecode to binary code. Bytecode to binary code is by the interpreter, Java interpreter. So it is Java interpreter. Yes, interpreter. So interpreter, Java interpreter. Okay. So bytecode to binary code by the Java interpreter. So Java interpreter converts bytecode to binary code. Okay, bytecode to binary code. Bytecode to binary code. Then executing simply. That binary code given to processor. Binary code given to processor. Okay, binary code given to processor simply, right? So once given to processor, then generating outputs. So a program, Java program compilation by the compiler. Program compilation, errors checking by the compiler. If no errors, runtime. Program execution by the interpreter. So here errors checking by the compiler. Program execution by the interpreter. Now I am using Java interpreter for running here. See first Java compile, Java C tester Java. Java C means Java compiler. So Java compiler, C means compiler. Java C, Java compiler used for error checking. No errors. So generate one dot class. But now I'm using Java interpreter. This is Java interpreter. Java interpreter test enter key. That's executed. Now here is used interpreter. Error checking purpose Java compiler is here. Execution purpose now interpreter is right. Interpreter is. See in case of Python case only one thing is right. In C++, C language, only compiler used. But here two things involved here. So compiler and interpreter both involving here. Compiler and interpreter here. So errors checking by the compiler. Errors by the compiler. Yes, runtime by the interpreter. Okay. So errors checking. Error checking by the compiler. Error checking by the compiler. Error checking by the compiler. A runtime. Yes, runtime. So runtime by the interpreter. Program running by the interpreter. Runtime by the interpreter. By the interpreter. Right? Runtime by the interpreter. So errors checking by the compiler. Runtime by the interpreter. Runtime by the interpreter. So what is happening here? So first test.java, right? Test.java program. So what is this? Is a source code. This is source code, right? It's source code. Source code file. This source code file given to Java C compiler. Now result of Java compiler is what here? Yes, tested dot class file. No errors. Tested dot class file generated. It's a bytecode. So this is bytecode. Bytecode, right? Bytecode. So why this bytecode? Intermediate code. This intermediate code, bytecode. Bytecode, intermediate code. Why this bytecode is here? To make the Java as independent platform. To make the Java as independent platform, that bytecode concept was introduced here. So why bytecode concept introduced in Java? To make the Java as independent platform. Now, so you get dot class, right? Why dot class file concept introduced? To make the Java as independent platform. Yes, we'll discuss. The topic cards we'll discuss. So test.java source code is given to Java compiler. Test dot class. That bytecode file generated. Now this is given to Java interpreter. So next you see this interpreter, Java interpreter. It's Java interpreter. This is Java interpreter. Interpreter. So interpreter. Now interpreter taking that bytecode here. So bytecode converting into binary code. Converting into binary code. So that binary code given to processor. Binary code given to processor. Okay. Then finally generating output. That is what is happening here. That is what is happening Java here, right? What is happening Java? Okay. Now tell me, Java depends on what? Now Java depends on what? Java depends on what? Is it compiler based or interpreter based? Java depends on what? Is it compiler or interpreter based? See, Python is a interpreter based, only one interpreter. C is a compiler based. Now tell me, as per my explanation, as per this explanation, now Java depends on what? Java depends. As per this explanation, yeah, depends on both. Right, correct. Depends on both. So Java depends on yes compiler as well as compiler as well as compiler as well as interpreter. Interpreter. So compiler as well as interpreter. Compiler as well as interpreter. Okay, compiler as well as interpreter. Okay, right? See, 1 second. See, last point here. Here's some point. 8 points. Interpreter based language don't have exe file. Interpreter based language don't have exe file. Okay. Yes, last 2 minutes over, almost completed. See, any language, runtime is an interpreter based. Any language, runtime is interpreter based, don't have exe file. Try to understand this point here. Any language, runtime is an interpreter based, no exe file concepts. If runtime is interpreter based, no exe file concepts. Like runtime, program execution, runtime is program execution. Program execution by the interpreter, no exe file. See, Python script executed by the interpreter, no exe file. HTML script execution by the interpreter, yes, no exe file. Right? Okay, so any language, runtime is an interpreter based, no exe file concept. Any language, runtime is interpreter based, no, you don't have exe file. Okay, yes. Java, come to Java. Java language. Yes, Java language. In Java language, program execution by the interpreter, right? Java language runtime is an interpreter based. Okay, Java language runtime is interpreter based. Now question is, yes, can we create exe file in Java? That's the question. That is question. Or yes, is there any exe file concept? Is there any exe file concept in Java? Exe file concept in Java. That is the question. Yes, Java depends on both compile and interpreter. Okay, fine. See, any language runtime is interpreter. Runtime program execution by the interpreter, no exe file. In Java, program execution by the interpreter. So any exe file concept in Java. So as per this point, as per these 2 points, tell me. Yes, as per these points, can we create exe file in Java? Is there an exe file concept in Java? See, try to understand this point here. Any language runtime is interpreter based, no exe file. Don't have exe file. Java language runtime is interpreter based. Java language runtime is interpreter based. When Java program executing by the interpreter. If executing by the interpreter, no exe file. Not Java. Any exe file concept in Java? Yes, can you answer this point? That's right. No. No exe file concept in Java. Okay. So can we create exe file in Java? No. So no exe file concept in Java. No exe file concept in Java here. No exe file concept in Java. Here everything is dot class file. Everything is dot class file. Everything is a dot class file. Everything is dot class file. Okay, but dot class file is not exe file. Dot class file is not an exe file. Exe file is different. Dot class file is different here. What is exe file? What is dot class file? Tomorrow topic. Tomorrow features. Tomorrow discussing features. For tomorrow topic, so this is the prerequisite. Today's topic is a prerequisite to understand tomorrow that all that features. Okay. So here, so Java no exe file concept, everything is dot class file. So dot class file is not exe file. See, same points explain document also. See the document. Interpreter and compare that all the differences very clearly explains all the differences. Same difference explained here. See what is Java? Java depends on both the compiler as well as interpreter. Both the compiler and interpreter. Yes, Java errors checking by the compiler. If no errors generating dot class file. Dot class file is a bytecode file. Java runtime by the interpreter. See, same that points. Source code to bytecode like this. Okay, like the same thing. This point same. Okay. So these are the steps in this. First step by the comparison, next step by the interpreter. Okay. So Java. See Java depends on both the compiler as well as interpreter. Java runtime is interpreter based. See any language runtime is interpreter based, no exe file. Since Java runtime is interpreter based, no exe file concept in Java. So can we create exe file in Java? Can we create exe file in Java? No. There is no concept of exe files in Java. Yes, everything is a dot class file. Okay, dot class file is not exe file. See here, dot Java, then dot class. Have you seen any dot exe file here? In this step, Java program compiled and executed, we got the outputs. In this process, have you seen any exe file? No exe file. Did you observe any exe file? No. No exe file. Dot Java converted dot class. Dot class is not exe. Exe is different. Dot class is different. The topic tomorrow. Tomorrow Saturday we'll discuss. Saturday also taking classes. Monday to Saturday class. Okay. Yes. No exe for it. There is no exe file concept in Java. So this is yes. Java depends on both interpreter as well as compiler. So this is introduction. Java introduction. Now Java features. This topic tomorrow will continue. Tomorrow finishing Java features. Okay, after finishing Java features, next installation topic will be on Monday. Okay, tomorrow we'll discuss about features. We'll continue for the features tomorrow. Okay. Yeah, that's all. Yeah, thank you guys. Thank you for listening for more time today. Yeah, that's all for today. Any doubts? Yes. Are you understanding guys classes clearly? Are you able to understand? Is understanding classes clearly? Yeah. So thank you guys. Yeah, we'll continue tomorrow. Okay, see you tomorrow. Same time, 11:45. Same time, 11:45. Okay. Yeah. Thank you guys. Yes, tomorrow Saturday also taking class. Monday to Saturday classes. Okay. Only Sunday holiday. That's all. Thank you. See you.